All right, welcome back. Let's take a look at this. So we are basically on day 2 of the laws of exponents. You guys worked with multiplying exponents. You have the same basis. You add your exponents together. And so essentially when we divide exponents, we're actually going to do the opposite. So we're only working with bases that are alike at this point. When we divide powers of terms with the same base, you are going to subtract the exponents, the smaller from the larger, to be specific and to be exact. It's always going to be, only if you have the same base can you subtract the smaller exponent from the larger. So the difference of the powers will always go wherever the larger exponent started. So the first 2 examples that you're seeing here on the flip chart is, in the first scenario, the numerator has a power of 5, the denominator has a power of 2. So if we follow what the instruction says, we are going to take the difference of the 2 exponents, taking the smaller away from the larger, 5 minus 2. And the difference of 5 minus 2 will give you x to the third. So essentially, when you work this out, and you actually would expand this out, this is why it works. This is why the answer turns out to be x to the third. If you take x to the fifth and you expand it out, x times x times x times x, okay? And then in the denominator you have x times x. Remember that when you simplify, you're literally canceling on top of each other, the like things, the like bases. So when you cancel, it ends up canceling out to 1. X divided by x is 1. X divided by x is another 1. So that leaves you with the 3 x's in the numerator, x times x times x. And in the numerator, yes, 1 times 1 will still give me 1, but we're never going to leave that 1 in the denominator. In the second example, we had x to the 4th on the numerator, x to the 6th on the denominator. So again, my larger exponent happens to start in the denominator, larger one's in the bottom. So we're going to take the difference from where it started as the larger one. Take the 4 away from the 6, leaves you with a difference of 2. So again, expand it out if you don't see it. And in the numerator, x times x times x times x. In the denominator, x times x times x times x times x. Again, simplify. Cancel, 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 cancel. So now in the numerator, you're left with 1 times 1 times 1 times 1. Leave in the denominator 1 times 1 times 1 times 1 times x times x. So notice that these answers are exactly alike. Shortcut, find the difference of the powers. The long way, expand it out so that you can see what's going on. Take a look so that if you get confused, you can always expand it back out and start canceling. So we want you to use your shortcuts if possible here. So in example number 3, if we follow the same rules where the bases are the same, 6 is my base, my exponents of 12 and 5, keep the base the same, find the difference of the exponents. 12 is larger than 5, so I'm doing 12 minus the 5. Base stays the same, find the difference, and we're looking at a difference of 7. It's done. Don't make it complicated. Try the next 2. Simplify it so that where you have bases are the same, you're subtracting their exponents. The fourth example that you're taking a look, you might have an expression that has more than one variable. You might have an expression that has more than one base involved. And so if we have that, we're still going to use the same rules. We're going to work with the same bases on the x, the same bases on the y, and we're going to apply the same rules, and we're going to take the difference. Make sure you're taking the smaller away from the larger. So if I'm just working on the x's, x to the 9th is larger on top. So I'm going to take away the 2 from the bottom. On the y's, when I compare those two, the y to the 5th is larger on the bottom, so I'm going to leave it on the denominator and take away the 2 from the numerator. So simplify that out, and you've got x to the 7th over y to the 3rd. Again, you can't do anything else to that. It's already simplified. X is now being combined as one term, and so as the y's. So dividing fractions with the same bases. One more example is if we throw in a problem like example number 5, take a look. The 2 and the 4 and the 2 are just like any regular fraction. You're going to treat it like any regular fraction, and you're going to reduce. I can reduce by 2. I can reduce by 2 again on the bottom and get 2 over 1. But then go back to your new rule, same base, x to the 4th over x to the 1st, find the difference. So I'm left with 2 on the coefficient, x to the 4th, take away the 1 that was in the denominator. On the y's, I'm looking at 6 on the top, take away 1 from the bottom, and the numerator all just became 1. So simplify, 2x, find the difference, that's 3. Find the difference on the y's, that's 5. Remember, a division of 1 will not change the value. So example number 5 should finish as 2x to the 3rd, y to the 5th. Always simplify, simplify, simplify. Right. So that's the front side of your handout. So make sure you got the U-tries completed before you move on to the flip side. So what happens when the exponents are negative? So when the exponents are negative, your scenario changes slightly. You're going to end up moving negative exponents because we can't leave our answers with negative exponents. It's not proper. So when you are looking at negative exponents, you're going to move it to its opposite location. If the negative exponent term starts in the numerator, you move it to the denominator. And the exact opposite, if that negative exponent term starts in the denominator, you're going to actually move it to the numerator. So essentially when that occurs, your exponents will change to its opposite. That's how we get rid of those negative exponents, by changing them so that they're changing their location. We call that a stay and go method. So if you have a positive exponent, stay where you are. If it's a negative exponent, go somewhere else, okay? Take it and move it to its opposite location. And then you're going to simplify using your multiplication and your division rules on exponents. So when you take a look at the first example, I gave you a negative exponent of 3. So essentially right now this 7 base is in the numerator. I'm going to move it to the denominator. So I'm left with 1 on the top. Move the base of 7 to the denominator, and then your exponent becomes its opposite. That's it. In the second example, notice that I started with an exponent in the denominator, and I'm going to move that to the numerator. So that actually becomes the base of 5, and now the 2 that was originally negative in the denominator, bringing it to the top in the numerator, it now becomes positive 2. The one that was originally there, it's still there, but it's being multiplied, so really it's not going to change the value. So 5 squared. This is just learning how to undo that negative exponent. So if the negative exponent's in the numerator, bring it downstairs to the denominator. That's your stay and go. We're going to go and move the negative exponent in the denominator. We're going to go and move it to the numerator. So in the next example, notice that both exponents are negative. So we're going to bring the 10 to the negative 3 to the top. We're going to bring the 10 to the negative 2 to the bottom. So we're switching places so that we can change the exponents to their opposite. So 10 to the third, and then 10 to the second. Notice the location, notice that we changed the exponents. And then simplify one more step. You're going back to what we just did on the flip side, the front side. The bases are the same, subtract the exponents. Base stays the same, subtract the exponents. So our final answer really is a difference of 3 and 2 becomes 1. And 10 to the first is simply 10. So I'm showing all the work that goes behind simplifying this. In the fourth scenario, when you have 0 raised to the negative 3, yes, I'm going to bring this downstairs. I'm going to bring it down to the denominator. So I'm left with 1 on the top, 0 raised to the positive 3. But can 0 ever be in the denominator, folks? And the answer we're all going to yell out is no. So in this particular problem, this is what we call an undefined situation. And so if you put it in your calculator, it's going to tell you it's undefined, and you can't do it. It doesn't exist when the denominator is in, or the 0 is in the denominator. It just doesn't exist. It's undefined. Okay? All right, so we've got the first 4 examples. We've got more to do. Again, what if there's more variables involved? So essentially, stay and go. We're going to move these exponents with their bases so they're in the opposite location. I'm going to leave x to the 7th. That's going to be my stay. And I'm going to move the x to the 2nd to the denominator. That's going to go. Y to the 5th that's in the numerator. That's going to go also. And then the y to the negative 3 that's in the denominator is going to go upstairs. So if you look, you'll notice that all my exponents are now positive. And then I'm going to go back and simplify. All the rules that you now have learned with multiplication and division with like bases. So in the numerator, y to the 3rd will stay as y to the 3rd. The denominator, notice your bases on the product of x to the 2nd and x to the 7th. Remember, add your exponents. You're looking at 7 plus 2, which is 9. Y to the 5th stays on the bottom. And then finish it up. I can't leave y's on top and bottom. I've got to simplify one more time. And I'm going to actually take the difference, because I have like bases, and I'm going to take the difference in the denominator. So x to the 9th is done, but y to the 5th minus 3 will simplify as y to the 2nd. So we're simplifying so that the x's all get eventually combined, all the y's get combined. And then we're going to try one more example. Just like I said on the previous side, if you've got coefficients get multiplied and divided, simplified like they regularly would do at any point. So the negative 3 and the negative 6 can simplify to a negative 1 and a positive 2. So simplify those two values. That's what you're going to end up with. Let's work on stay and go. So I've got 3 bases with negative exponents. I'm going to move all those, but I'm going to leave x to the 2nd on top. That stays, but everything moves to its opposite location. X to the negative 4 comes to the top. Y to the negative 3 on top goes to the bottom. The y to the negative 6 on the bottom goes to the top. So I'm going to simplify what I can. Negative 1 times x to the 2nd, x to the 4th, same bases, add your exponents. In the denominator, I still have 2y to the 3rd, and I've got y's that I can simplify further on. So I'm going to have like bases on my division here, 6 minus the 3, so I'm going to simplify that one further out, x to the 6, and then y 6 minus 3, will end up giving me to the third. So all the x's eventually got combined together, all the y's got combined together using multiplying and dividing exponent rules. So you've got 2 on your handout that we want you to give a try at. Examples 4 and 5. Which ones stay, which ones go, okay? And then simplify. So one last concept. You guys know this. Remember, anything to the 0 power always equals, and what are we going to shout out? Yes, you guys remembered. Anything raised to the 0 equals 1. So that entire expression, 5x to the negative 2, y to the 7, the entire base is raised to the 0, well, that whole expression will equal 1. And so we'll do some practice in class, give it a try, and we will see you next class.